Hello, this is Mark from Jeter Tutors, and I'm getting no video. Hey, there we go. All right, so this is Mark from Jeter Tutors. Before you go any further, make sure you subscribe and like the video. This video is really for a particular group of students who are dealing with rational polynomial functions and their vertical and horizontal asymptotes. And the reason I'm making this video is I want to help you guys to see, guys and gals, to see how the tricks of finding, in particular, the horizontal asymptote is really not what your teacher wants. He wants you to understand the math behind it, and as far as the limits are concerned. Okay, there's a reason why the rules of your quotient will yield either an asymptote at a particular value, of y equals, say, 1/3, or no asymptote. Okay, so those rules, if you have seen in other videos, and hey, kudos to all you guys in the other videos. I watch PatrickJMT. You're awesome, dude. You're like so thorough. You have videos on everything. I'm just trying to fill in the little gaps and help my students out. So what we have here is a polynomial where the degree of the numerator is less than the degree of the denominator, and what that's definitely going to do when you take the limit, okay, is what that's going to do is it's going to force the denominator to be really, really big compared to the numerator, okay, which is going to create a situation, and this is what your teacher wants you to see, is you want to take the limit as x goes to infinity of x minus 1 over x squared minus 3x plus 2. So as this goes into infinity, this actually is going to be, this here is going to be a larger, if you want to say, it's like a larger infinity. Okay, so this is like x over x squared. Okay, and the reason why we can do that is because we're ignoring the other terms. Basically, as 3x goes to infinity, it's still going to be a lot smaller contributor than x squared. And of course, the 1 is a constant. So you get this function here, so you get basically 1 over x. Now, as x goes into infinity, this is 1 over infinity, which is equal to 0. Okay? So now if you get what they'll tell you is this, that if the degree of the polynomial in the numerator is bigger than the degree of the polynomial in the denominator, the asymptote, the horizontal asymptote, is y equals 0. But this, my friends, is why that rule works. Okay, not the other way around. Okay, the reason why the rule works is because these lower degree polynomials, lower degree terms, excuse me, basically disappear, and you can rewrite these functions, or this quotient, as something that makes sense. That's something that you can actually evaluate. Okay, so there's an example of finding the horizontal asymptote. Okay, so you can pause the video and kind of digest that. Now I want to just look at the vertical, because I labeled it in, I colored it in red. Now when you're dealing with the vertical asymptote, like I had in the beginning of the video, it's pretty much kind of like an easy thing, right? It's, you know, I like this problem because you'll see there's some nuances to it. Pretty much you're looking for when x squared minus 3x plus 2 equals 0. Okay, because that's bad. Okay, right? That's a bad thing. We can't divide by 0. Leibniz and Newton knew that, and calculus was born because they created the limit and stuff, and figured out how to defeat the zero dividing by zero problem. And that wasn't just them, but it was collaboration between them. But they get all the historical credit. So all right, so what we have here is something that's factorable. So x minus 2 times x minus 1 equals 0. Okay, so you would say, oh, well, x equals 2 as a root, and x equals 1 as a root. Okay, now the problem with just saying, okay, there's a vertical asymptote at x equals 1 and a vertical asymptote at x equals 2. There's a problem with that because when you plug in this here, what do we get? We get a 0 in the numerator. In other words, we get the evaluation of 0 over 0. Now, when that happens, we know that there is a hole instead of an asymptote. Now, okay, for those of you who are not like in a class doing this all the time and stuff, I'm probably like, what is he talking about? But for those of you who this video is made for, you know exactly what I'm talking about. That's a hole. When I put in 2, it's not a hole. You get 1 over 0. If you get something with a constant over 0, that is going to be an asymptote. Okay? A vertical asymptote. So far, I wanted to show you too also how this shakes out. So far, excuse me, I was going to say we have a horizontal asymptote at y equals 0, and we have a vertical asymptote at x equals 2. Now, there's another way you can approach this, is that you can basically factor this, okay, and simplify, okay? So you wouldn't run into this issue of having that, what I almost call an extraneous solution, or the hole, when you're looking for your vertical asymptote. You won't run into that if you can do a little bit of factoring and simplification, okay? So now we get 1 over x minus 2, and we can then say, well, if this is the function, then I hope the chair is not in the way. If that's the function, that's 1 over x minus 2. Then x equals 2 gives us the vertical asymptote, the line x equals 2. Okay, so I just wanted to show you that it's okay to do some simplification, okay, because you're not really losing anything by doing that. You're not losing any validity. In fact, but you may want to simply make sure that you have those two solutions so that you can say whole and 1 over 0 vertical asymptote, right? So that indicates the vertical asymptote. So you might want to keep that, but hey, you haven't really lost anything. So I hope that this helps to explain what the teacher's really looking for as far as the limits, okay, for the horizontal asymptotes. Now, in order to find, now if y equals 0 is your horizontal asymptote, let's try to sketch this thing out, okay? We have vertical asymptote, excuse me, at x equals 2. So as x goes to infinity, okay, as this goes to infinity, this gets really, really small, okay? This gets really, really big, and this gets really, really big, but everything's really, really big positive, okay? So what that tells me is that it's really, really big positive as x goes to infinity. What am I? Oh, sorry. I know that. Excuse me. It's really, really small. Excuse me. Really, really small because this is really, really big. So as x goes into infinity, so I just had a brain fart. So right here, you're seeing we're on the positive side of the asymptote. That's what I was trying to get at. And we know that this goes near, it approaches 2, but it will never reach 2. Okay? Y equals 0, HA, VA. Okay? Now, that said, if you come here, we know we have a hole. We have a hole at x equals 1. So not really an asymptote, but we have a hole. So this is going to be, if x is, say, some positive number between 0 and 2, okay, then that's going to be negative. So this is 2. 2 minus 1 is 1. It's 1.5. So all the way to 1. Okay, this is going to be positive. This is going to be positive. And this is going to be negative. So 1 minus 3. Well, less than 1 minus 3 is going to be negative. So say x is a half. So that's going to be 1/4 minus 3/2 plus 2. And this is going to be negative 1/2. Okay? So we're going to get, say, 2 1/4. So we're going to get a negative number. So 2 1/4 minus 1 1/2 is 0.75. Okay? So we're going to get a negative number. Okay? So we get a negative number down here. And so x is a half. It's like here. We get a negative number. Okay. And so then this does that. Okay. Now here's the deal. Right here, there's going to be a hole. It's still gonna go that way. Okay. So remember, we have a hole at 1. Okay. And we found that because when you put x1 in for this, this becomes 0. This becomes 0. You get 0 over 0. Okay, so that, I believe, is the correct graph. If you find any errors with that, leave in the comments below. I just wanted to do the graph part of it at the end to kind of complete it out. But the beginning of the video, first couple minutes where it talks about the limits, okay, applying the limits directly to the function, is where you're gonna apply that logic of which terms don't matter and which do. Okay, and that's the little bit of work that your teacher wants you to know. So I hope this video wasn't too long, and you guys have a good night. I know the quiz is coming up. Thanks. Bye. Don't forget to subscribe, like, leave comments below. Till next time.